right? It says find 3 intervals. Remember when intervals are of x, of length 1 that are guaranteed to have a 0. So we have a cubic polynomial. How many zeros could it have? It could have at most 3. They've already told us to find 3, right? This is a calculator process. So we're going to have to put this in the calculator to see what we see. Right? So y equals, clear, 12x to the third minus 32x squared plus 3x plus 5. And let's look at the graph. In fact, let me zoom out. Zoom 3. Okay. Now, what we really need to look at is not the graph, the table of values. So if I look at the table of values here, notice that between -1 and 0, between x is -1 and x is 0, the value of the function went from -42 to 5. I mean, looking over here, it was -42 and now it's +5. Doesn't there have to be a 0 in between those two? Right? That's what they mean by that. Find a 1-unit interval that you can tell has to have a 0 in it. There must be a 0 in between -1 and 0 because it changes sign. Right? Where's another 1-unit interval that you see there? Between 0 and 1, it goes from 5 to -12, right? So there's another, and what's the last one? Between 2 and 3. So this is purely something you do in your calculator. You look at the table of values and you say, okay, here's your intervals. -1, 0, 0, 1, and 2, 3.
What's the order?
It doesn't matter. It has to be, each one has to be the lower number on the left, the higher number on the right. Okay. Now, the reason that we do this problem is because it makes us use what's called the intermediate value theorem, which is something in calculus that you'll use quite a bit. And it's actually, that's the intermediate value theorem. But the way that it's worded in the book, you can see it's right before this example. It says that if A and B are real numbers such that A is less than B, okay, you could say like -1 is less than 0, right, in our example, then if f of A does not equal f of B, in that case, right, f of -1 did not equal f of 0, one was negative and one was positive, then the function must have every value in between what it had at -1 and what it has at 0. And since one was positive and one was negative, we know that means there's a 0. That's what the intermediate value theorem says. There must be, every function value in between has to be in there. And another point, why is that true? Because what do we say about the graphs of polynomials? They're continuous. There's no way that it could like somehow jump from the negative value that it had at -1 to the value that it has at 0 and not somehow cross the axis in the middle. There's no, it's a continuous graph. So when you put all that together, you can say, okay, it's going to have a value in between those. For your homework, I mean, there's going to be a problem like this, but you won't really be thinking so much about this. You'll just remember what we did in the example. Put it in the calculator, look at the table of values, see where it changes sign. Josh.